Okay, this is test 3 of the official College Board SAT 2016 guide. This is the no calculator section. A painter will paint n walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH. Okay. If the customer asks the painter to use a more expensive brand of paint, so that's more money, right? Which of the following factors will change? Well, the one that involves dollars, right? So K is a constant with units of dollars per square foot. So that number is going to increase in response to the more expensive brand. If 3R is 18, what is 6R plus 3? So you can solve for R here by dividing, but another way to do it is to double both sides, and you get 6R equals 36. Then you could plug this in for the 6R here. 36 plus 3 is 39. Which of the following is equal to a to the 2/3 power? So we know that this is going to be power over root. So we can say that it's a squared cubed root. The number of states that joined the United States between these years is, so we're going to let that be sort of, usually I'd let that be x, but I think they want x to be the later one, so let's have this be y. Is means equals twice the number, this one is the one they want for x. If 30 states joined the Union in the first period, so they're telling you that y equals 30, which of the following equations is true? So we can plug 30 in for y. We get 30 equals 2x. That's choice B. Alright, we have to solve this. So we can cross multiply. Right? We remember that anytime there's a division bar with a binomial or trinomial, we have to put parentheses on it. So we get this equals 15x. Distribute the 5. We get 5x plus 100 is 15x. Subtract 5x. 100 equals 10x. Divide by 10. We get x equals 10. Sorry, but then we have to realize that they're not asking for that. This is a partial answer. 10 over 5 is 2, right? So trying to catch you napping a little bit there. If xy is a solution of the system of equations above, what is the value of x minus y? All right. So whenever you see this and they're asking for some combination, usually that means you should try to stack and solve, otherwise known as elimination method. So either we add or subtract the lines. In this case, I'm going to add the lines, and I get 5x minus 5y equals minus 20. It might not seem right away obvious as to what I'm going to do next, but basically what I'm going to do is divide by 5 on each term. Another way to think about it is you could factor out a 5. That would leave 5 minus y, and then you could divide by 5 on both sides, and that would say x minus y is equal to this, which is really negative 4. The function f is defined by the polynomial. Okay, which of the following must be a factor of f of x? So this is the key part here. They're asking about a factor of f of x. So the thing to know here is that basically we're looking for where y equals 0. Right? We're looking here because factor has correspondence with a root. Okay? So a root is where it's also known as an x-intercept. Okay? It's where your y value is 0. So once you had a root, let's say the root is x equals 3, that means that x minus 3 was the factor, right? So you just have to do the opposite. It's kind of like if you were to, if you were to do this process backwards, okay? This sort of t-chart and factoring, right? Right, but this time we're starting with the root and we're kind of going up north one step to get to here, you see? So anyway, 4 comma 0 is the point that we're interested in, all right? Which means that at x equals 4 is where you have a solution. Therefore, x minus 4 would have to be a factor. The line y equals kx plus 4, where k is a constant, is graphed in the xy plane. If the line contains a point CD, what is the slope of the line in terms of C and D? Okay. So usually whenever they give you a point, you can kind of label them as x, y and plug them in. So that would be d equals k times c plus 4. And then we can solve for the slope, of course the slope being k, right? So we get d minus 4 equals kc. Then we divide by k. Divide by c. We wanted to isolate k, right? So we get d minus 4 over c. In the system's equations above, k is a constant and x, y are variables. For what value of k will the system have no solution? Okay, so for a system to have no solution, that means that the two lines have to be parallel to each other. Therefore, they don't intersect at all. Okay, so for two lines to be parallel, they have to have the same slope. And they have to have a different y-intercept. Because if they had the same y-intercept, then they would be the exact same line, which means that they would have an infinite number of solutions. Anyway, so all the slope information is contained here on the left side. Alright, so we need these left sides to be equal. So how can we make that happen? Well, we can start by trying to get the y terms to be equal. So we'd have to, for example, multiply by 5/3 on the top one. I think that should do the trick. So then we would get 5/3 kx minus 5/3 times 3y equals 5/3 times 4. So then these 3's would cancel, and that would give me the minus 5y that I was looking for there. And here you get, 20 over 3. And here, 5/3 kx. Okay? So now, the middle terms are the same. So you got 4x minus 5y equals 7. So you got the middle terms the same. Now we have to demand that the first terms are going to be the same. So to do that, we have to make our equation. 5/3 kx has to equal 4x. I can cancel out the x's, right, just by dividing x on both sides. Then I have to isolate for k, so I move the 3 up and I move the 5 down. You could also think of that, about that as multiplying by the reciprocal on both sides. Anyway, you're left with 12/5. In the xy plane, the parabola with the equation this intersects the line with the equation this at 2 points. What is the length of AB? Alright, so x minus 11 squared, alright, that has x equals 11 as a root, right? It causes y equal to 0. So that's here. And in fact, it's a double root, which means since it has multiplicity 2, it just bounces off of that root. It doesn't go through. Right? You learned about that in later Algebra 2 or even pre-calc. But even if you didn't know that, you can graph it on your calculator. We want to know where this intersects y equals 25. All right? So basically, it's these 2 points here. And again, very easy question to graph on the calculator, but it's also pretty easy to do by hand. But since we want to go the easiest possible route, let's just use the calculator, right? So we'll go y equals, we'll clear it out, and we'll go x minus 11 in parentheses, x minus 11, and we square that. And then the next line we'll do 25. We'll see where they intersect. So the graph might need to be standardized, so we'll go zoom 6. And since that's a little off the mark, you can actually do zoom 0, which will kind of fit it where it thinks you want to look. Okay. Well, that gets one of the intersection points, but we might want to zoom out from there. Zoom 3. Okay. So I'm not really seeing the second line, which means we probably zoomed out too much. Yeah, let's go to a height of 25 and zoom back in. See, this is a great opportunity to use the window feature, because the problem is that our x dimension is very wide, but our y dimension we want to be more narrow. So let's take a look at that window function. And we want our y maximum to be much smaller. Okay? We know we're looking around a height of 25 is where we're interested in. So let's put our y maximum at, let's say, 27, and our y minimum at, let's say, 23. let's see what that would look like. Okay. All right, so here we can clearly see the line y equals 25, and yeah. Are those both the intersection points? It seems to be so. Right? So we can kind of look at where they are on the x-axis. This one looks like it's about 6, and this one here looks like it's about 16. Right? Now, if you weren't confident in that, you can do your second calculate, right? Intersect. Right? First curve, second curve. And there it finds for you 6, 25. But anyway, this one's at x equals 6. This one's at x equals 16. And they want to know if those are points A and B, what is the length of AB? Well, it goes from 6 to 16, so it's length 10. And of course, as I mentioned before, you can do this whole problem algebraically by plugging in 25 here, foiling this out, and then solving the corresponding quadratic that you get. All right, in the figure above, lines K, L, and M intersect at a point. If x plus y equals u plus w, which of the following must be true? All right, so we already know a couple things just based on the geometry here. By vertical angles, we know that y is equal to u. And we also know w is equal to z for the same reason. And we also know that x is equal to t. All right, so let's start with those equations along with the equation they're giving, which is x plus y equals u plus w. Now we can make substitutions into this equation to determine something new. So the first thing I would look at is, since y is equal to u, maybe I could plug in a u for that. Okay, when I do so, I notice that these u's will cancel out, and I'll get x equals to w. And that's some new information, so I'm going to add that to my list here. Okay. Now, if you notice, I have x equals t, and I also have x equals w, so that means all three of those are equal to each other. And I also have w is equal to z. Okay, so that means all four of those are equal to each other. And the only one that's different is y and u, potentially. Okay, so I know that x is equal to z because you can see on my chain of equals here. And does y equal w? It doesn't seem to be the case. Does z equal t? Yes, indeed. So I know 1 and 3 are certainly legit. So anything that doesn't have 1 or doesn't have 3 is out. And then I have to decide about 2, and I'm going to decide that it's not legit, right? In the quadratic equation above, a is non-zero. The graph of the equation in the xy is a parabola with vertex CD, which of the following is equal to D. So again, whenever you see a point, label it xy, and that kind of tells you what you can do with that information. In this case, would that be helpful? Maybe. But more so would be our understanding of what a parabola is. Okay, so a parabola has got a vertex, and it's also got two roots. Okay, and the vertex is in between the two roots in terms of the x values. It's smack dab in the middle. Okay, so also known as the average. So we could grab those two roots. That would be helpful. And we could do that by t-charting. Here we get x equals 2 and x equals -4. So -4 and 2, we can take an average of those, okay, by combining them, dividing by 2. That gives you -2 over 2, which is -1. That must be where your vertex is, at an x value of -1. So we know that c is equal to -1. We just need the corresponding y value to go with that. That one, to get it, we would have to plug -1 in for x in the original function. Okay, so we get y equals a times -1 minus 2 is -3, and then -1 plus 4 is the same as 4 minus 1, which is 3. So that's -9a, choice A. Okay, this equation is true for all values of x, where a is a constant. What is the value of a? Right? So we have this equation here, and we have to solve it. So there's several ways that we could do this. The first way that I think of is I think of taking this term to the other side, where it has a friend with the same denominator, you see. So if we do that, then we end up with minus 47, right, over ax minus 2. Now, since this would then become plus, if we brought it to the other side, right, it would be a plus 53 with the same denominator. So I can combine those two fractions and put it sort of like that, right? And anyway, that's going to equal minus 8x minus 3. And at this point, now to start solving this thing, I have to clear the denominators. So I have to move this denominator in this direction, you see, ax minus 2. Okay, so I end up with this. Now, of course, I'm going to have to FOIL out the right side, but I'm also going to combine like terms on the left side. So plus 25x, and then I've got a minus 47 with a plus 53, and the plus team wins by 6. Okay, and then here I'm going to FOIL, so it looks like minus 8a x squared, and then the outer would be plus 16x. The inner is going to be minus 3ax, and then the last is going to be plus 6, right? So now, right away, I notice that there's a plus 6 on both sides. So if I subtract 6, it cancels out from both sides, right? Then I also notice that I've got a 24x squared, and I got a minus 8ax squared. So that means that 24, the coefficient there, has to match the coefficient here, minus 8a. So if I divide by minus 8, I'll learn that a is equal to negative 3. And that's what the question asks. What are the solutions to this? Well, one way to do it is to plug them in. I wouldn't really try factoring this because, if you notice, the choices are showing irrationality, you see. So you might be better off using completing the square method or quadratic equation. And similarly, you can also plug it into the calculator if you're really at a loss, and then find the roots and work your way back one step to find, well, basically it would give you a decimal, so you'd have to see what the decimals are for each of these. But anyway, my first step will be a factoring step. I could factor out a 3, 4x plus 2. Then I divide by 3 on both sides to just get rid of it, okay, because 0 over 3 is 0. And from here, I'm going to do completing the square, right? Just to refresh everybody on that method. The first step is to take this plus 2, bring it to the other side, and make it minus 2. Okay. Now that leaves a space here, and that space is filled by what's called the key number. So to find the key number, you take half of the middle term here and square it. So half of 4 is 2. 2 squared is 4. You add that to both sides, and I like to circle it so that I remember to add it to both sides. Okay. Then we factor down this left-hand side trinomially. So the plus will drop here, and then the same sign, 2 and 2, adds to 4 and multiplies to 4. Now we have here 4 minus 2, which is 2. I can rewrite the left side as a perfect square, okay? Because whenever you have the same thing multiplying itself, it's equal to that thing squared. At this point, I can then square root both sides. And I have to remember to put a plus or minus on my radical 2, because whenever you square root both sides, you always put a plus or minus, right? And if you notice, I left a little space there so that when I minus this 2, it kind of fills that space, right? So x is negative 2 plus or minus radical 2. So that's choice A. Okay. The equation above shows how a temperature F measured in degrees Fahrenheit relates to a temperature C measured in degrees Celsius. Based on the equation, which of the following must be true? Okay. So the first thing, I look at this as a linear function, okay? And yes, you could distribute this 5/9, and that will tell you the slope and y-intercept. But certainly the slope is 5/9, you see. And slope can be interpreted as change in y over change in x, right? So that means that the change in y, now y, mind you, is the notation that's used for the dependent variable, right? The one that's changing in response to your input. So for our symbols, that's known as c, and our independent variable is delta f, okay? So the change in Celsius over change in Fahrenheit is 5 over 9, okay? So that'll be important for what's to come. And item 1, a temperature increase of 1 degree Fahrenheit is equivalent to a temperature increase of 5/9 degrees Celsius. Well, that is actually true, as you can see here. A delta C equaling 5/9 corresponds to a delta F of 1. Okay? So I'd agree with that. Item 2, a temperature increase of 1 degree Celsius is equivalent to a temperature increase of 1.8 degrees Fahrenheit. Alright, so we know that these are in a 5:9 ratio, right? So if I wanted a 1 where the Celsius is, okay, then I'd have to put sort of an x where the Fahrenheit is, and I'd have to solve this system, or not system, proportion. So I get 5x equals 9, and then divide by 5, x equals 9/5, which, yes, indeed, happens to be 1.8. So I would get a change in 1.8 on the degrees Fahrenheit. So this is also true. A temperature increase of 5/9 degrees Fahrenheit is equivalent to 1 degree Celsius. Well, that can't be true, because the opposite of that is true, right? It's 1 degree Fahrenheit for 5/9 Celsius, not the other way around. So I'd say 1 and 2 only. And by the way, that's question 15, which is typically the hardest question on this no calculator section. Now we're in the grid-ins. Okay. If x is greater than 0, what is one possible solution to this equation? Well, there's a few approaches that we can take. We can try plugging in numbers like 1 and 2. Not the ideal way to do it, but it's a possible alternative, right? But in this case, we're going to take a different approach, okay? So what we should probably try is to maybe simplify this thing. So the first thing I would think of to do would be to sort of get rid of these extra x's by dividing by x to the third on both sides. That may help. Let's explore that. So the reason why we're allowed to do this, by the way, because we know x is greater than 0. If x was equal to 0, we wouldn't be allowed to divide by x on both sides. But anyway, here we get minus 4 over x squared. One of those x's was canceled with that x there. Okay. From here, let me just bring the x squared back this way now. Okay. So again, I'm moving it across the equal sign. So we get this, and then I'm going to distribute it in. I get x to the 4th minus 5x squared equals negative 4, and then I swing the negative 4 to the left side, making it plus 4. Okay, and then leaving a 0 vacancy on the right side. Now this should look a little bit familiar, because it kind of looks like a quadratic, except for its higher order, right? So this is a reducible one, because all the powers are even, 4th, 2nd, and this technically the 0 power, right? So anyway, if you're uncomfortable with it, you can make the following substitution. Let y equal x squared, so that whenever you see y squared, that would equal x to the 4th, right? Because it'd be x squared squared. So now I can replace y squared with x to the 4th, and with x squared I can replace it with y. So now we have a quadratic in y, and then we can factor it down using trinomial methods. So we put the minus sign first, and then this tells us the same sign because it's plus. So the number is going to be 4 and 1 because those combined up to 5. So anyway, we get y equals 5 and y equals 1. But then we have to remember that y is really x squared. So x squared equals 5 and x squared equals 1. So x squared equals 5 means x equals plus or minus 5 square root. And x squared equals 1 means x equals plus or minus 1 square root, which is still 1. So the solution I would choose here is 1, because out of those, it's the easiest to grid, right? Gridding rad 5 wouldn't be so easy. And it's positive, which is important because that was a hypothesis of the problem. If this is true, what is the value of x? Alright, so the first thing I would do is combine these x's together. So you have 7x over 9 minus 4x over 9. That's going to be 3x over 9, right? And then similarly, I have to combine the right sides. I can do that by multiplying 3 on top and bottom here. Get 3 twelfths plus 5 twelfths, which is really 8 twelfths, right? Good. And then I can still reduce these down. So this is really 4 times 2, and the bottom is really 4 times 3. Okay. So the 4's can cancel, and I get 2/3. So this is the whole thing there is 2/3. Now, the 9 on the bottom here is really 3 times 3, right? And one of the 3's can cancel. The other one's still there. So now, if I want to isolate for x, I can move this diagonally, so it lands on top. And these 3's will cancel. So I find that x equals 2. Alright. Question 18 is next. Two isosceles triangles are shown above. If this is this and this is this, what is the value of x? Alright, so we have to plug in 75 for y. Okay. And this is an isosceles triangle, as is this one. Well, I can also plug in 75 here, right? So that would be 150. Then I could subtract 180 in an attempt to isolate for z. I get negative z equals negative 30, so therefore z equals 30. So now I can plug that in here. Now, if I was to call this by some letter, because I don't know the value, let's say f, because x is already being used, then this one would also have to be f, because this is an isosceles triangle, which means it has base angles that are equal, right? The base angles being here. So that means that if I add up these 3, they have to equal to 180, right? So then subtract 30 from both sides, and that gives me 2f equals 150, and divide, and you get f equals 75. So I know, for example, that this angle here is 75. Then I can use 180 minus to get the supplement here, because this forms a straight angle. As you can see, this arc is half a circle, which has 180 degrees in it. X plus 75, subtract 75, and you'll find that x is equal to 105 degrees. So we would grid that in. Okay, last two. At a lunch stand, each hamburger, right, hamburger has 50 more calories than an order of fries. So hamburger is 50 more than fries. All right, I could just tell this is going to be a systems of equations. Now, if 2 hamburgers and 3 order of fries has total calories of 1,700, then how many calories does a hamburger have? Okay, so there's our setup, and we're looking for h, right? So the most obvious way to solve this is to take this, which is already isolated for, and plug it in for h over here. So we're using substitution method, but we have to keep in mind that eventually we're going to have to back solve to find h. So anyway, we plug this in, plus 3f equals 1,700, and then we distribute the 2. 100 plus 2f plus 3f equals 1,700. So that's 100 plus 5f is 1,700. We subtract from both sides, and 5f is going to equal 1,600. And then we can simply divide by 5. And we find that f is equal to 320. But again, that's not our final answer, because we have to then plug back in to get h. Luckily, it's not so hard to do. So we plug in the 320 that we got for f right here. 50 plus 320 is going to give 370 for h. And that is what we would grid in. In triangle ABC, the measure of B is 90, so I'd better make it look like a right triangle. ABC. BC is 16, AC is 20. All right. Triangle DEF is similar, right? But DEF is 1/3 the length of the corresponding sides. Okay, so it's a smaller one. Here's DEF, and it's smaller. Now, what is the value of the sine of F? Okay, so they want to know the sine of F. Now, if you know anything about similar triangles, you know that what makes them similar is they have the same shape, right? And by shape, what I mean is that their angles all match up, right? All three of them. And you know that when you study geometry, you learn that you need to use angle to prove that two triangles are similar, because the third angle is automatic. But anyway, I know that C and F are the corresponding angles, so they must be equal. So instead of finding the sine of F, I may as well find the sine of C, which is going to be equal to it anyway. And to find the sine of C, I have to do SOHCAHTOA. So sine is opposite over hypotenuse, right? So from C's perspective, this would be the opposite side here, and of course this would be the hypotenuse. So it's the unknown side that I actually need to figure out. I need this opposite. So to figure it out, I can use Pythagorean theorem, or I can use my Pythagorean triples. So I know that 3, 4, 5 is a right triangle, and any multiple of that would also be a right triangle. So in this case, it looks like I'm multiplying by 4. So if I times each of those by 4, I get 12, 16, and 20. So the missing number there is 12. Okay, so that would go here. So anyway, my opposite side is 12, and my hypotenuse is 20. But that's not quite griddable until I reduce it. So I remember that this is 2 times 6, and this is 2 times 10. Those 2's can cancel. Then this is really 2 times 3, and 2 times 5. Another set of 2's can cancel. I end up with 3/5, and that is griddable.